afternoon, my dudes. We're going to do a real quick one for you guys today. It's been great. It's middle of the week. Want to talk through the new Intel, what they're about to announce, and what's known right now that's been at least produced out there. Anadec Forum did a good piece on the details of what they have within the Intel and what the chip's going to be. We're talking Bitcoin mining ASIC, and I've ran some numbers. I'm going to share you guys a spreadsheet. We're going to add to that spreadsheet a few different things like power, cost, and just estimations. And I'm going to take you guys through some of my thought process when I look at something like something new coming out, such as like a new ASIC like this, are the things I think about, and then which plays into this. We're going to run through some speculation. We're going to run through form factor. We're going to run through when Intel's doing research on where these ASICs would go in comparison to, where Bitmain and some of the other architecture that's out there. If we're talking what's miner, stuff like that, like it's more than just the the advantage that the chip has from a wattage standpoint, from a gigahash per chip. It's also like how many can they get on a board and what's the form factor. So when you're thinking about any kind of new piece of hardware, you're thinking also where is it going to go. Form factor matters, especially in Bitcoin mining, on two dimensions. One, what's the size of this ASIC? Is it going to be the same form factor size as an S19, or is it going to be the same size as a what's miner? Right? There's a physical difference in form factor there. How wide is it going to be? How tall is it going to be? And then what's the depth, right? Those matter because certain mining farms around the world have been built around a design of what the current hash boards and architecture between what's miner, which really mimics the S9s, and then the S17s and S19s, where they have a larger box, and a lot of farms had a retrofit when they moved to that, that side. So I'm going to bring up a kind of a breakdown of what that looks like, and we're going to make some estimations. We're going to make some estimations on the silicone and the fabrication size. So if we're talking 7 nanometer architecture, if we're talking 5 nanometer architecture in the size, we're going to look at the current known or at least published power ratings on that, and then how many chips could be per hash board if they kept the same kind of design architecture as a S19. And then we'll look at how does that impact, because these numbers are a lot lower, meaning if you've built out a facility based on containers and you're setting at 1.3 megawatt potential on a container, with like 360 units in it, and you move to something like the Intel one that comes out, you're going to be using about a third. So like it's a space, the space consideration is as much as anything else, because now you kind of overbuilt for that as the technology stack comes. So, things that maybe Intel's thought about or not, but let's get into this. We got some people on right now. More people will join. I kind of went unannounced with you guys online because I'm between a whole bunch of different things right now, and I'm just this is essentially my lunch hour. So I'm streaming my lunch hour with you guys to get some content out there and just take you guys through what I've been looking at when it comes to planning, when we're talking buying ASICs and all that kind of stuff. So let's switch over to, first off, the Anadec article. So if we switch back over to this is the article I'm talking about. And this is the Intel 2 generations of Bitcoin ASICs, the BZM1, and then they have the BZM2 that's announced on a 5 nanometer architecture. So this one's built on 7 nanometer. What this means, like anybody that's mining like with GPUs, the RDNA 2 stuff that we're using on the AMD side is the 7 nanometer architecture, to give you an idea. When you look at what their setup and their design is, they show an example of an M30-S88T as an example. So this essentially is like roughly 21 chips per row, and you have so many rows. You're looking at like 384 chips on like the Bitmain ASICs. You have 3 hash boards. So you can start to kind of do some math with some of these numbers from a fabrication standpoint. So the Bitmain chips are 7 nanometer, and how many chips, at 29.5 millimeter with that fabrication, assuming that the sizing's pretty close to appropriate, how many could you get in there physically? Can you go 4? I did see somebody in the comments, they asked, said they're feeling like they'll go with a rack. The problem with changing that form factor is all the current build outs. You're not going into data centers, right? You're going into containers. You're going into places that have been retrofitted with a design for crypto miners that are a certain size. So they're going to have to think of, will people retrofit? People did retrofit from S9s to S19s. Are they going to do it again, type of thing? We look at the table here, and I have a spreadsheet that kind of breaks this down into some other numbers for you guys. So I'm kind of crawl, walk, running you guys in through the strategy here. So you look at the Intel BZ M2 and the M1. So the M2 is not announced, any of the specifications is not announced yet. But assuming that it's using 5 nanometer, because I don't think Intel's at 7 nanometer on their fabrication side yet. So TSMC right now is at 5 nanometer. And we look at Samsung and some of the other ones that are kind of getting to that edge of 5 nanometer. We'll see where things are going. I think Intel's skipping over 5 nanometer. I think they're going straight to 4, but I'm not 100% confirmed on that. I just know that I've read some things into that they may be going into 4 nanometer. But if we look, here's the couple numbers that I want to make sure before we switch to the spreadsheet, you guys see and understand. So when we talk about the hash chips, these little guys are on the board, right? Each one of these, and it's like they're doing it in series, right? So they're like right now on the S19J Pros, they are 270 gigahash each. This is why you guys will see some of the USB miners. So they're like the USB miners that you don't use that much power. They are using, they're essentially putting a chip like this on there, a single chip, has all the the infrastructure to be able to run, and you can plug it into USB because it uses like 7 watts, right? So then you have all these little USBs with a single chip on it, and you're getting 270 gigahash. The funny thing is I look back in the day on ASIC tech. My old jalapeno from Butterfly Labs was 8 gigahash for like 50 or 60 watts, I believe, or maybe it was 100 watts at the time, right? So it's insane how much further the tech has gotten. 8 gigahash for like that much wattage to now these little chips that are doing 270 gigahash for like 8 watts, 7 watts, somewhere around there. So when we look at, the specification here, and it's like 7.99 watts. So I need to update my spreadsheet. You'll see here in a second. And then you have the Intel chip right now that's reported at 137 gigahash for 2.5 watts, right? So let's switch over to the spreadsheet real quick, and let's look at this. So I got these numbers in here, and don't worry, I'll zoom in if people can't see them. Let's go like this, and then let's zoom in over here, just to get you guys some stuff. So what I did is I took, this is the Bitmain. So if I merge these cells and call this the Bitmain S19J Pro, and then let's copy that over here and just call this the Intel BMZ1. The BMZ1, is that what they call it? BZM. Intel BZM1, right? So 7 nanometer, 2.5 watts, 170 gigahash. Now, these are assumptions. I'm going to highlight these things in assumptions. So yellow means assumption. So we're going to assume some things that if the fabrication and the chip size was close to the same as the Bitmain, and let's say they had 3 hash boards. Now, it might not need near the cooling. It's about half the output there. We're going to change this to 7.99 watts, which should change all of my figures here. So that moves us to this. So your delta on the overclock here, 11%. So what this is showing is that at 270 gigahash per chip at 7.99 watts, you get a total gigahash on an S19J Pro of about 92.3 terahash. So the thousandth position here is a terahash. So the 92 part of that is terahash. Now there's a base overclock. So they take the base chip output and then they do some tweaking, firmware stuff, and they get this chip up to 104 terahash, right? And then you have what they call bend chips that are a little better. And then you can get some of those up to 100, a little faster and use a little more power. Instead of 3,068 watts for the machine, you're now at 3,200 watts, but you can bring this up to 110 terahash. And that's really where you get your difference. You get your bend chips that can run a little faster. Sometimes they have a little more chip head count on them, but that's what your output is. So you look at the power overclock, it's about 11% increase to get it from 2733 to the 3068 watts of power. So this is 104 terahash unit, 3000 watts of power. So understand that's the current baseline of anybody that's building out a farm. You're building your power around that. You're setting your 30 amp direct plugs in for 3000 watts of power. You're essentially one Bitcoin miner per 30 amp at that rate. If we took these numbers forward and said the fabrication was the same or close to the same, hashboard architecture the same, 243 chips, or 342 chips, we would be at a rough estimation based on 170 gigahash, that many chips. I'm left these in here. I'm going to upload this spreadsheet for you guys too, and I'll put a link in this description, so don't freak out that you don't have this. You're going to have a base set of about 58 to 60 terahash for that unit at 855 watts. So that's a base level wattage. Now let's take an assumption that it's 11%, right? Like if you had the same calculations here, even if I doubled that, let's say to try to get it to 65 terahash unit, we went to 1,000 watts. We're using 22% more power to get 65 terahash. You would be roughly 37.9% less hash rate. However, you're using 2,000 less watts, right? So if I take the container concept here and I look at a container, now this is speculation. We don't know. We don't know how many chips are going to get on a board. I'm taking an assumption that the fabrication, if close to the same 7 nanometer, and the chip, that's going to designate how big my chip is going to be, or pretty damn close to it. So then that means to have the same form factor as an S19, I'm going to use about 3 hash boards with 342 chips on that. What's that size going to be if I'm trying to match that form factor? Well, I know that if that's going to happen, then I'm going to be, and let's say I double the amount of overclock, which probably is going to be 11%, not 22%. I'm going to be setting at 1,000 watts, not 3,000 watts. And I'm going to be setting at 65 terahash, not 104. But that changes my calculation a little to where now a current typical 40-foot container for Bitmain, 360 units. It's about 37.4 petahash right now for that per container at 1.1 megawatts. A Intel setup with that same design, with the same amount of chips on the board, speculation, we'd be at 20 petahash at 0.3 of a megawatt. Like, huge difference. Like, let's say your power cost was 0.06, okay? And we'll do a little power cost calculation. So let's do power cost calculator, energy calculator. We're going to say, was it 337,50,000 watts? 24 hours a day at 0.06 cent calculation. Energy costs, we need a little more than that. 375,000, 24 hours a day, 0.06. Cost a lot more than that, my dudes. Did we break it? It's kilowatts. Not kilowatts. Watts. 375,000 watts, right? Where are we at? 375.16. There we go. That is off, my dudes. That's not calculating correctly. Let's do it this way. Kilowatts, 375. We broke their calculator. 375 kilowatts. That should be megawatts. We broke their calculator. Oh, it's 6. It's not 0.6. That's what it is. It's already doing the calculation, my dudes. I thought there was something off there. There we go. So reading helps. So 6 cents per kilowatt, not 0.6. That would be really cheap power. Can you imagine that? That'd be 6,000th of a freaking cent. Like, that's almost free cent. That's almost free. So you're looking at 16,000 a month, 16,200. At 0. Let's say 6 cents month. Put this in the dollars. And then let's go into, don't mind Miss BBT coming in there. Let's see here. Let's go here. Let's go here. Let's do 1103. Huge difference, my dudes. 47,600. Here. There it is. So that's the difference power-wise. Now, granted, we're a third less, right, of total hash, or not even a third less. We're what is it? We're 37% less hash rate, but we are 3 times the cost, almost 2 times the cost. I'll tell you right now. This minus this divided by this. 66% less cost. Like, it's going to be a big change. But it all comes back down to the form factor. I still think it comes back down to the form factor. So if I'm a farm owner and I have a container and the form factor is the same, and I'm going to use a third less electricity, I don't, even at 6 cents per kilowatt, I don't care about the electricity use as much, right? Like, I'm built out. I care about the electricity use. I don't care that I do care the fact that I'm not using my capability, because I would have made the expense and the power cost expense for 1.3 megawatt. Now, granted, over time, things are supposed to become more efficient. But what I'm saying is Intel speculatively should be understanding that the power threshold of where these locations are at, that they have the capability, at least in a container standpoint, to handle 1.3 megawatts. So packing enough chips in there to bring the mega hash up to meet that is going to be an interesting thing. So let's go one more further step on this and speculate how many chips and how many hash boards would they have to meet that requirement. So it's just the other inverse of that algebra, right? So if we're talking 170 gigahash and that gets us 65, what's it going to take to get the power? What if we do it based on the power? So it's essentially a 3 times. It's 66% more. So we would be at this times 66%. Nope. Oh, Excel doesn't like me changing. Hold on. Okay. Let's add this. And then let's do a plus on this. So 560 some odd chips would put us at a base of 1400 watts. And let's say that would get us to 2000. So it's actually more than that. It's actually more than 60%. Let's say 120%. That's 1880. Let's say 170%. Now we're getting close. That's 1,000 chips. That's a huge piece of equipment. Like the fabrication design on that is going to have to be crazy. Like, and this is to match the power, right? Let's do 230. I know there's a faster algebra way to do this, but I like the fun of getting it up there. So this is close, right? So we're looking at, let's just call it 1,090 chips. Okay. That would then get us to that base level there. And if that was the case, 1,090 chips on an ASIC at that rate, hash rate would be 186 terahash at the same power baseline as an S19. It's just the numbers. Based on what we have, this is the speculation of where we would be at from a total gigahash. And actually, this number needs to be here because we would still be able to probably overclock those from their baseline. So that number needs to be there. And then let's say that there was a 20, let's say that they were still able to hit the same ratio as this. That's this from a wattage standpoint to match the Bitmain percentage increase from base. And you're looking at the base wattage here. Where am I at? This one here. This is fun doing Excel. Oh yeah, I have it. That times plus this. There we go. So 3,035 watts, which actually I need to do this one. Here. I need to move this down. That would be this times the 11%. So we'd be right at 200 terahash. Potentially. If it was trying to match the same power profile as Bitmain's S19. So if you were wholesale taking that unit and keeping the same power output to match your configuration of what you have from your 30 amps and your setup, you'd be at 200 terahash with 1,000 chips at an 11% overclock on base, based on what we know right now. So 200 terahash unit. And then you would be up to this. Let's take this whole thing here. And let's just copy it under here. Right? So total gigahash would be this times our output now. No. Is that right? Holy. No. 360 units times total overclock gigahash. Oh. This is 104. Yeah, this is the same, my dudes. It's 20,000. Hold on. We're off on something. Oh, I have to do I have to add something here. It's actually more. It's actually more, my dudes. 206. 206. So 75 petahash. A 75 petahash. Let me scroll down. I'm doing stuff where you guys can't see. Hold on. Here we go. $74.2 petahash. Total wattage would be the same or pretty close to it, which would be this many units times base overclock. So you'd be at you'd be at one total megawatt. So it'd be 1.09 megawatts, and essentially it would be, you would essentially be this, really close to this price here. 092 calculate, you'd be at, yeah, real damn close. $47,000 price point per month. That's at 6 cents. Do we have any estimation of the price of it? Nobody's seen any numbers or price. But I mean, you could create a cat. So if I was Intel and you're looking, you know what your core costs are. You could speculate what they would do the algebra on that much hash rate if they were trying to keep it competitive, right? So how much more is this compared to this? We know what the price of the Bitmain is, right? So then let's say if this was their actual numbers, it's a 50% increase, net change. I mean, it's double. It's actually double. So you could assume $19,000, $18,000 on this unit if it was the same. That's what I would speculate at. I would speculate that it would be $18,000 for the Intel unit if it was putting out 200 terahash at 3,000 watts. So again, all speculation. I'll upload this file up to you guys for you guys can have it. Let me get. Oh, we had somebody do some gifts of subs. Mr. Lau, like a boss, doing a 5 gift subs. Thank you, sir, for that on the Twitch folks that are watching. Do appreciate that for the Twitch folks. And we saw a couple super chats there too. Thanks for those super chats, my dudes. Let's get me switched over to this. So hopefully you guys like this kind of content. I'm doing this off to the side anyways, just to kind of figure out like form factor, power usage based on that chip architecture. Again, this is complete speculation. Can they get 1,000 or 1,100 chips on their system? That's a lot. but based on their output, based on the amount of stuff, that could be a 200 terahash unit at 3000 watts, which fits the power profile. So 3000 doesn't have to be the standard, but it's the macro side that I'm looking at there, where people have made a sunk cost and an investment in power infrastructure. And if they're not leveraging their entire power infrastructure, the thing that they're going to look at is like, well, how do I get another box hooked up to this? Because I have a transformer that I paid for, and I want to use that 1.3 megawatts that I've had. Because most of those power deals are the total usage. Like, so if you've done like a 10 megawatt deal or even a 2 megawatt deal, you may be getting charged for all that 2 megawatts. So guess what's going to happen? You're going to put another box there. You're going to have more incurred costs because you have to put another container. And then you're coming off that transformer. So if Intel does it right, they're going to build a form factor that fits within the current container structure, the current building structure, thermodynamic structure, and they're going to try to match it up to the competition. And you're going to see a maximization of that. Based on the chips that we're looking at, this is the numbers that came through it. All right, my dudes. Quick 30-minute shot. Hopefully you guys like this. Make sure you're liking and subscribing. We're going to have a reduced version of this for people that just caught it late that we're going to put together, that are just going to talk to the numbers real quick, probably 5-7 minute video. And then we'll be bringing some new content to you guys. Make sure you're following us on Twitter. We got some new stuff coming out on Twitter. I'm going to show you guys. And we got a new office, another new office warehouse thing that we're going through a build out. We're going to take you guys through that build out too. This is really to get us structured and ready to go for some of the rapid deployment stuff that we're doing. So awesome, my dudes. I will catch you guys in a bit. If I missed a question or anything like that, you guys can always hit me up on Twitter, and I usually respond to those pretty quick. So just hit me up on Twitter or drop a question down below in the chat, and then we'll get her done. All right, my dudes. Peace.